Jim to visit me in China in 2001, and Jim and Marilyn came. And afterwards, I saw him in Setauket, and I was very impressed with the short conversation I had with him. I said, Jim, how's your impression of China? It's his first visit. And he sort of paused for a few seconds. I realized that this has been on his mind. And he said, well, I think the problem facing the world today, the most important problem facing the world today, is poverty. And he said, here, in my visit, I found 1.3 billion people pulling themselves up out of poverty by their own bootstraps. And that is a contribution not only to themselves, but also to the world. I think it's very clear that that reflects the thinking of a thoughtful person who, upon reaching a stage in his life when he can try to do something good for mankind, not just for himself, would perhaps think about. So I was deeply impressed by that statement.
Okay.
Dr. Simons, you've been involved in a number of philanthropic efforts, including healthcare in Nepal, including, of course, all the help you've given here to Stony Brook and to the Brookhaven National Lab. Tell us a little bit about philanthropy and how you go about making the decisions that you do.
Well, the biggest single focus we have right now, we have a number of foci, but first of all, our foundation and our philanthropy is primarily based on scientific research. That is, supporting mathematics and science basic research. That's what and we spend 80% of our funds on that. One thing you didn't mention is the autism
right.
initiative that we have, and that's probably the biggest single project we have, and there we're quite focused, and we've put up a team under the leadership of Jerry Fischbach, who's a well-known neuroscientist, and to run that, and we're trying to make some progress with that condition, which really goes to the heart of, in many respects, of how the brain works. Understanding that condition is going to end up giving us a lot of understanding of how a normal brain, an unaffected brain works. And so it's quite scientifically very challenging. But basically, our approach is to support basic scientific and mathematical research for two reasons. One, because we think there's a lot of leverage in that one can do a lot of good by making progress in these basic kinds of areas. And two, it's interesting to both Marilyn and me. We both like research. I get into it a little bit. I've learned some neuroscience. Obviously, I'm a mathematician, so maybe I could get into a little bit about what we're doing here. But so it appeals to us aesthetically as something very interesting and something we both like, and from the first point of view.
Autism is, of course, a very important subject now. There's very little known about it, isn't that?
Well, of course, if everything was known about it, then it wouldn't be such a problem. It's genetic, that's for sure. Two identical twins, if one has it, the other is 90% going to have it. So at least beyond the spectrum, it's a broad range of conditions that have a number of things in common. So the first fact is it's genetic. The second fact, and now we've been looking for genes. There's going to be a large set of genes that impinge on this, probably at least 50 from different places in the genome that are going to create what's called autism. Presumably many of these affecting the same pathway or the same subsystem. In other words, there are a lot of things that can make a car go wrong, not drive. Maybe the spark plugs are no good, or the carburetor is no good, or this or that. Any of them relates in a poor performance of the car, but they may be different things. So, and most of these genes, the genetic condition is probably going to be turn out to be what's called sporadic. In other words, you don't inherit it from your mother, let's say. It's not found in her genome, but it might be a damage in her egg, or perhaps more likely in your father's sperm. So there could be, at the germ cell level, some damage at the time of inception, some genetic damage, which then becomes in the infant's genome. And so it's not classically Mendelianly inherited. You don't say, oh yes, well, old Uncle Ned had it and he was passed down and so on and so forth. That'll happen, but most of it is probably going to end up being this. So there's a big hunt on for genes. We're doing a big data collection at 11 sites around the world, collecting uniformly characterized genetic information, bloods and so on, and a lot of questionnaire type stuff, phenotype information. So that's a project that we're doing. And I'm very optimistic that within 3 years, I would say, most of the gene candidates will have been identified, and some discovery will have been made already as to how a few of these major ones work. There are already some mouse models being made of a couple of the most flagrant suspects. And so I think that the next 3 years is going to see a lot of progress. I think the next 5 years. I think within 5 or 6 years there may be some interventions based on what we've learned here, something to stimulate or slow down some particular process that's inhibited or accelerated or whatever it might be. So, and it will break down into subgroups. Even though there's 50 or maybe even 100 genes, there's probably a half a dozen subtypes that come out. I mean, there's a lot to be learned. There's a lot to be learned.
You sound very hopeful, though. I mean, that's
I'm very
the most
hopeful.
Optimistic assessment of autism I've ever heard.
Well, I'm very, very hopeful. I mean, I think there's a clear path. It's genetic, let's find the genes. Find the genes, let's see what they do. There's a clear path. There will be progress on this path. Will it be wiped out or 100% treatable? I doubt it very much. Will a reasonable amount of it be treatable? I'm optimistic.
You reject the fairly widespread notion that it's somehow connected with vaccinations, for example.
Well, there's not a shred of evidence. If there was some evidence, I might, all the experiments that have been done in large samples have shown absolutely no difference between large groups that have been vaccinated and similar groups that have not been vaccinated with this mercury or thimerosal or whatever. So if there were evidence, sure, but there isn't any. The reason I think that people are suspicious of this, one thing, there's a tremendous desire to, people really want an answer, because it's a terrible thing to have a child, in particular who's severely autistic. It's a terrible thing. And secondly, about 15% of autisms are regressive. It means this, that in about 15% of the cases, a child will seem to be developing normally through roughly the age of 2, and then go backwards, lose language, maybe lose some coordination that he or she had, and so on. It's a regressive type. That happens to be roughly the time at which kids get one of these multi-shots. So a lot of people say, oh, well, she was fine until she got that rotten shot. Well, maybe it was a month before or a month after or something like that. But there's no causative connection that anyone has determined between those shots and that behavior. But that would be I mean, look at all the people who still think living by a high tension line, that electromagnetism is going to give you cancer. Now, there's not a shred of evidence of that, but there are still people who say, hey, you know, I don't believe it. They're out to get it. So, anyway, I'm sorry I talked too long.
No, that's perfectly fine. Where do we go from here in your fields, your respective fields? Just as a way of sort of wrapping this up, Dr. Yang, where are we going? Where are we headed in physics, for example?
This is a question which is oftentimes raised by my students when they talk to me, because that affects their future very much, of course. I always say that if you look at the history of physics in different periods, there are completely different types of problems, completely different flavor of development. And for a young person looking forward to a future in physics, he or she must understand something about the changing environment. And I especially emphasize what was the situation 1 century ago is no longer the situation today. A century ago, there were fundamental problems in physics which need to be solved. And Einstein and Heisenberg were born at that time. So they created the great revolutions. Today, we don't have that opportunity. Does that mean it's bad for you compared with my generation, especially compared with Heisenberg's generation? Yes and no. If you want to make revolutions, I think you are less fortunate. But on the other hand, usually people do not make revolutions. People make small progress, very useful progress, very rewarding progress. And there you have an advantage. Because today, the field of physics is very wide. Many, many doors are open. And if you go into the right door, you might make some very important progress in the field of lasers, in the pace of superconductivity, in what I called this morning about the cold atoms. The technology advance makes it possible for human beings to explore matter in many more ways than it was possible for Einstein's time or for Heisenberg's time. So you should think of this as a challenge and as an opportunity. It's a different type of challenge. But if you ask me, is physics full of important future prospects? I said, of course. And furthermore, in fact, if you do the right thing, you might become a billionaire, because all these new channels, how is the modern computer created? The modern computer depends on the chip. The chip depends on the semiconductor. And semiconductor is a field of physics. And if you do the right thing today in the semiconductor field, for example, if you can make a semiconductor-like device which solves the heat transport problem, you would become immediately the head of you could become immediately the head of a company worth $1 billion. So there are many more opportunities today for you to make achievements of various kinds compared with Heisenberg and Bohr's time. I think, so if you ask me, is physics a good field? Answer is unambiguously yes. Is it a good field for revolutions like Einstein's? No.
Dr. Simons, what advice would you give young mathematicians or young investment advisors? Take your pick.
Well, I'll try to be brief. I think one can summarize some of what Frank is saying, is that he said physics is broader and so is mathematics, in particular on the application side. So I think there'll be a lot of progress in mathematics on the theoretical side, as there always has been, but mathematics and quantitative methods in general are more and more ubiquitous in applying to a whole range of areas. Finance today is riddled with quants. Obviously, Google didn't even exist 20 years ago, and so on and so forth. So there are many, many opportunities for people in mathematics or with mathematical training, yes, to do great research, but also to do a variety of things. And in another interview, perhaps we could get on to our failures to educate the young people in the country, but it can't be now, because I'm going to go to the 2 o'clock lecture.
I look forward to the next one. Thank you very much, Dr. Simons,
Okay.
and you too, Dr. Young.